So this is our lesson on, chapter 11 dealing with circumference and arc length. The majority of chapter 7 deals with different areas of shapes. We do get to volume at some point. But for this lesson, we're just talking about different parts of a circle. So the only thing I need you to recall really from this section is the formula for circumference of a circle, which is all the way around the circle, how long that is 2 pi r. Some textbooks have pi d. That's the exact same thing. And I know that that is true because 2r, or twice the radius, is equal to the diameter. But I tend to use 2 pi r for whatever reason because it seems that most textbooks give you the radius first. So if we wanted to give one example to find the circumference, I need to see this work. I want you to write out whatever the information is. So I'd be saying C is equal to 2 times pi. So we're just going to highlight that real quick. Actually, let's do this one since that one's not highlighted. Come on. 2 times pi times whatever the radius is, which is 5. Leave your answers in terms of pi. So all I need you to do is multiply the integers together. So for this one, it would be 2 times 5 is 10. Pi stays at the end. I don't need you to enter in 3.14 into your calculator. I'm fine with this as your final answer. So if we were to try, let's do the next one. I could say the circumference is equal to 2 times pi times the radius, which is 6. We multiply the integers together. 2 times 6 is 12 pi. If they give you the diameter, you're in luck. You just have to say the circumference is equal to pi times the diameter, which is 100 pi in this example. Do change pi times pi to just pi squared, so the final answer would be 100 pi to the second power. You're done. Arc length is a little bit more work. If you want to fill this bubble in, the formula for circumference is 2 pi r, and then a circle has 360 degrees. I'm going to refer to this formula up at the top. You can ignore this one if you would like. To figure out how long this arc AB is, the whole formula is equal to the central angle that encompasses that arc. So this central angle is AOB over 360 degrees times 2 pi r. Once again, we are leaving our answer in terms of pi. So if we wanted to actually write out that example, let's copy this formula. We can fill it in. I wanted to figure out what the length of RS is. So right now I'm just putting RS without the specific symbols. It's going to be RS is equal to the measure of the central angle in the numerator, which is 60, always over 360, times 2 pi r. And the radius is 1/2 of the length of the circle, so 8. And then we're going to start to simplify. So I suggest dealing with the fraction first. So 60 over 360, we're just going to simplify the fraction, no decimals. 1 over 6 times 2 times 8 is 16 pi. And then from here, we can multiply the numerator times the whole number 16. So 1 times 16 is 16 over 6. And then pi just stays afterwards. Again, don't deal with pi. And then we'll just simplify the fraction. 16 over 6 becomes 8 over 3 pi. You're done. So the length of this is 8/3 pi. And the only reason I have these squiggles here is if you changed it to decimals, which I don't need you to do. MN, we're going to do the exact same thing. So the length of arc MN is found by taking the measure of the central angle, which is MON, and putting that in the numerator. So 120 over 360 times 2 pi r. And the radius is 6 centimeters given here. And then we start to simplify, which is going to be 120 over 360. I hope you know simplifies to 1/3. And then 2 times 6 is 12 pi. And then we're going to multiply. Let's move this over so we don't run into things. That's all right. I'll just delete this. Is going to be equal to 1 times 12 is 12 over 3 pi. And then I hope you see that one last time of simplifying. 12 divided by 3 is 4 pi. That would be your final answer. So the length of mn would be 4 pi. Again, leave your answers in terms of pi for everything.